Hello and welcome to another video that I'll be doing on solving linear inequalities. Let's just get into it. First things first, to understand an inequality you have to understand an equation. Now with the equation that you see right here, say for example x equals 3, that's pretty much going to give you one value. The only value that it's going to give you is 3. So for the most part, if x equals 3, that's where you are on the number line, and that's the only point, the only value. You get what I'm saying? So that's what it is for actual equations. However, when you're dealing with inequalities, like these two right here, when you're dealing with inequalities, you're not talking about one value. You are actually talking about an infinite amount of values. So now when you're dealing with these things, just understand when you're doing, say for example this says x is greater than -2, then you're talking about every single value greater than -2. And that's an infinite amount of numbers. Say over here we're talking about x is less than or equal to 1, you're talking about all the values less than or equal to 1, which is also an infinite amount of values. So really, that's the whole idea of inequalities. Solve the inequality and graph the solution. First, before we do that, we'll go over to just an equation. Equation, say 2x minus 5. If I was to solve this, right? Adding 5, that's 2x equals 8, right? And then x equals 4. Again, one value. So if it's one value, and that one value is 4. However, with inequalities like these, I'll write it out so you guys can see it. These things being inequalities, then when you solve these, no problem at all. You solve it just like an equation, but you have an inequality, so the graph is going to look different. So say 5x 17, that's really 5x is less than -15 divided by 5. X is less than -3. So pretty much you're talking about -3. All the values, nope, not close circle. All the values, not including -3. Just all the values less than -3. Same thing over here. If we're trying to solve a problem like this, you guys know how to solve a problem like this. Solving this problem is just x is what? Less than 3? I mean, I did the other way, but it means the same thing. That means 3 is greater than every single value of x. Remember, we're talking about an infinite amount of values, right? There are times we can get other kinds of solutions that might not, it might initially not make sense to you, but when you work it out, I'll explain. Other guys say 4x is greater than 2 times the quantity of 3 plus 2x, which is the same exact thing as 4x is greater than 6 plus 4x, right? Subtract 4x on both sides, you're going to get 0 is greater than 6. But 0 is not greater than 6. So we have to understand that this right here is a false statement. So if it's a false statement, then that means that there are no solutions. No solution will give you anything true. See, the one that we did up here, what this means right here is that as long as x is less than -3, then everything less than -3 is going to make this true. And I'm sorry, you couldn't see that. Anything less than -3 will make that true. And anything less than regular old 3 will make that true. Here, there's no value that will make 0 greater than 6, so there is no solution to that. Secondly, let's see this one right here. Let's bring this over and let's do some work on it. 2t is less than, I'm going to say positive 3 plus 2t. Subtract on both sides, what you're going to end up with is 0 is less than 3. Now this right here is pretty much, no, I don't want that one, a true statement. So with that being a true statement, then that means everything works. So there's an infinitely, I don't even know if I spelled it right, many solutions. In other words, all numbers will work here. So if you wrote all real numbers, that's cool too. I shouldn't say infinitely many, let's write all real numbers. So in other words, everything will work there. So we have that. Alright, we'll save the problems for class and let's deal with compound inequalities. A compound inequality is just two inequalities put together, right? So with two inequalities put together, you can deal with this the same exact way. It's just you're doing it on both sides, right? So say for example, we'll deal with conjunctions first. Inequalities that are joined together by the word and. So say for example you have x, well the way that you probably read it is -1 is less than x is less than 2. The way I would read it is x is in between -1 and 2. The reason why is because the two inequalities that you see here is x is greater than -1 and x is less than 2. Now there are values of x that can be both at the same time, greater than -1, less than 2. The way on the graph how this would look is you are going to be in between, as I said before, you are going to be in between -1 and 2. I can do better than that. 2. So now you're talking about all those numbers there, not all real numbers, but just all those numbers in between. That's pretty much what we call a conjunction. A disjunction pretty much is joined together by the word or. You're talking about all the numbers that can fulfill or satisfy both of these conditions. One condition, it has to be less than -2. X has to be less than -2. Second condition, it has to be greater than 1. And we're trying to find out where those numbers have to be. What numbers am I talking about? All the numbers that are less than -2. All the numbers that can go from here on, or all the numbers that are greater than 1. So the word or, it doesn't have to be in both. In fact, it can be in either one. It can't be in both. So it's going to be either in one or the other. So you're talking about those numbers. So pretty much, understand, just notice what a conjunction or an and statement looks like, and notice what an or statement looks like. Alright, so then from here we can solve the inequality and graph its solution. Say for example this compound inequality, this conjunction right here. I'll write down what it is. A conjunction. Right? And let's say first I will add 10 on both sides. That's a less than a. If I add 10 on both sides, over here is going to be, well actually, well let me back up a little bit. Because here's what you have to understand. You're solving two inequalities at the same time. The inequalities that you're solving is -4 is less than 6x minus 10, and you're also solving 6x minus 10 is less than or equal to 14. Both of those at the same time. These are easily solvable. So when you actually do solve it, you'll come up with x is greater than 1, x is less than or equal to 4. So really, you want to be greater than 1, and you want to be less than or equal to 4. So ultimately, you're talking about that range, that infinite set of numbers right there. So let me actually take this, and ultimately that's what you're doing. Let me bring that over here so we'll see that later. But there's another way to actually solve it. I can just solve both of them at the same time. So really, that's what I was doing earlier. In other words, add 10 to both sides. All two sides. Right? So then that means that 6x is in between 24 and 6. Notice it's very, very similar to the problems over here. And then divide by 6 on both sides. Divide by 6 here. Divide by 6 here. Divide by 6 here. And you'll get that x is in between 4 and 1, which is exactly what we just plotted. So you can choose how you want to solve these. That's totally up to you. In a disjunction, it's very much easier because it's already separated, and this is pretty much the way that we can go about it. So let me solve both of these, just like I'd solve equations. Alright, so now since I solved those problems, you can see that you have x is less than or equal to negative 2, or x is greater than or equal to 6. So since you have this word or right here, then you just have to be in one of those intervals and not both of them. Well, actually, you cannot be in both of them. You can't come up with a number that is less than or equal to negative 2 and greater than or equal to 6 at the same time. So it's either one or the other. So the way that we graph this is, first, x is less than or equal to negative 2, right? And we go this way. Or x is greater than or equal to 6. We go that way. Notice you can't be in both intervals, but those are two different sets of an infinite set of numbers, right? So pretty much that's ultimately what we're doing with inequalities. We'll do the word problems in class, challenge problem, all that other stuff. This is what I have for you so far. I'll see you when you get here.